Today we'll talk about empirical relation among mean, median and mode. Generally, we can see two types of relation between mean, median and mode of data. That's our symmetric relation and asymmetric relation of a data among mean, median and mode. And asymmetric relation are also known as skewed relation, and that's two types, that is positively skewed and negatively skewed. In this video we're gonna talk about the symmetric and asymmetric relation of the central tendencies, that's a mean, median and mode of data. So here in the left corner we can see a frequency distribution as a 3 frequency columns. Remember, generally don't use this kind of frequency distribution, but in that case I just used this frequency distribution to make you understand the entire topic easily. Let's consider the first frequency column of this distribution, and if we put these frequencies and the values into a graph, then you'll have a curve is like that, and it's a normal or known as bell-shaped curve, and here we put the values along the x-axis and the frequencies along the y-axis. After putting the values into a graph, we'll have this curve, that is bell-shaped curve. And here for this frequency distribution, by considering this frequency column, you'll have the result of mean, median, mode, that is all common measures of central tendency is 25. I'm not showing you the measurement of mean, median and mode in this video because this topic is not about the central tendency. Instead, this topic is about the relation of mean, median and mode. So in that case, for the first frequency column or for this curve, you will have the mean, which is equals to median is equals to mode, and the value of this 3 central tendency is 25. That is here. You can see along the x-axis the 25 is here. So you can see for symmetric or normal bell-shaped curve, we'll have the central tendencies, that's a mean, median and mode, is equal. So let's consider the second frequency column of this frequency distribution. If we draw the points and join them, you will have a curve like this, which is skewed curve. And to be more exact, this skewed curve is positively skewed curve. So how can you make a decision that it's positively skewed or negatively skewed? In that case, we have to compare the mean, median and mode, and if you measure the central tendencies, that's a mean, median and mode, then you'd have the mean, which is 21, and the median, which is 19.16. For this second frequency column of the frequency distribution, remember I have already measured it to make this video short, and the mode will be 16.66. In that case, if you compare the central tendencies, then you can see the mean is greater than the median, which is also greater than the mode. That means in that case the mean is greater than the median, which is greater than the mode. So remember, when the central tendencies, that's a mean, is greater than the median and median is also greater than the mode, the skewed curve will be known positively skewed curve. Let's write down here, that is positively skewed. And for the last curve or the first last frequency column of this frequency distribution, we'll have a curve like this by drawing these points into the graph. And in that case, if you measure the mean, median and mode, then you'll have the mean, which is equals to 29, and the median, which is equals to 30.83, and the mode of this distribution is 33.35. So in that case, if you compare the central tendencies, then you can see the mode is greater than the median, which is also greater than the mean. That is, the mean is less than the median, which is also less than the mode. In that case, we can see a relation between the central tendencies, which is reciprocal of the positively skewed curve or the positively skewed distribution. So in that case, we called this curve as negatively skewed. And as you can see, for the first graph is a bell-shaped curve. So here, this is a simple presentation about the relation of the mean, median, and the mode for a single data, along with the different frequencies. So here, for finding out the mode from the skewed distribution, a renowned mathematician named Carl Pearson have given us a simple formula to find out the mode. For the formula is the difference of mean and mode is equals 3 times of difference between mean and the median. And if we want to write it mathematically, then it will be mean minus mode equals to 3 times mean minus median. By simplifying this equation, you'll get mode is equals to 3 median minus 2 mean. Remember, this is an observation by Carl Pearson. So, as you know, the observation will always provide a approximate value or approximate result of a mathematical term. When we have a multimodal data and its mode is ill-defined, we can use this formula to find out the mode easily. In that case, you will have an approximate mode for this data, which can be found by this formula. Here we can see 3 types of relation between the central tendencies, that's a mean, median, and mode. And if we want to make a short summarization, then we have 3 types of relations, that's a symmetric relation, positively skewed relation, and negatively skewed relation. For this relation, we'll have this 3 curve. That's for symmetric relation, we'll have bell-shaped curve where the mean is equals to median and equals to mode. And for the positively skewed distribution, the mean is greater than the median, which is also greater than the mode. And for the last, that is negatively skewed distribution or curve, we'll have the mode is greater than the median, which is also greater than the mean. So our next video will be about the partition value of a data. Till then, take care and goodbye.